Good morning, everyone. Today we're going to talk about Archeopteryx. Number 6, Archeopteryx. You may wonder what this stands for. Well, this is the name that was given to a fossil that was found in 1861. It was found in limestone in Bavaria, in the town of Solnhofen. This is in Germany. You've got the red dot here to show you where the quarry where the fossil was found. The quarry looks like this. This is modern picture, but this is a site where lots of fossils have been discovered. The fossil itself looks like this, so it's quite amazing. If you're digging and you suddenly find this, well, that's made your day and possibly your life. It's quite an amazing fossil. And also it was a big mystery at the time. Why was it a mystery? Because in that time, in the 19th century, phylogenetic groups worked in this way. Scientists had stated that there was a group with birds, there was a group with reptiles based on similarities, and this fossil showed many problems because it had features from both reptiles and both birds. So scientists were not quite sure where to put this fossil. Is it a bird? Is it a reptile? Is it a bit of both? So your syllabus focuses a little bit on this part of biology history to understand why scientists didn't quite know where to put this species, and that's what we're going to do. Now then, to analyze a little bit this fossil, we are going to use a Europaea document, this one. So basically it's a drawing, a sketch of the fossil you just saw a photograph of. There are two things we want to look at. There are the characteristics which made scientists think it was perhaps a bird, and the characteristics which made scientists made them think it was maybe a reptile. So some typical avian characteristics, so things which makes it look like a bird. So you've got the different letters here. So A1, A2, A3, A4, and A5. They're pointing towards characteristics that birds have. So you can label them as we go along. So A1, true wings with feathers. You can see the feathers here. Arm skeleton, and the setup of bones that are here. The shape of the skull, which looks like a bird. Shape of pelvis, so A4, this part here. And one toe opposite the three others. So if we look a bit more closely, we've got one here which can bend towards the three others. It's opposite. You can touch one finger, all three fingers with the opposite one. So that's for the avian characteristics. Let's have a look at the other characteristics, the reptilian ones. I'm just going to raise. So now we're looking at, I'm going to change color, use blue for example. So let's have a look at R1, R2, R3, R4, and R5. So these are characteristics that reptiles have. Conical teeth, so the shape and the presence of teeth, because birds don't have teeth. Number 2, long tail with vertebrae. So if we draw, the tail here has vertebrae. Number 3, flat, weakly developed breastbone. So the breastbone is here. So it's not hugely developed. If you remember in previous videos when we compared skeletons, we saw that the eagle and the pigeon had quite a developed breastbone. Number 4, 3 fingers with claws at each forelimb. So you can see it here, claws at each forelimb. And number 5, the tibia, shin bone, and splint bone are not fused. So for birds, these bones here are fused, whereas here they are separated. So we've got characteristics which birds have. There are characteristics that reptiles have, so scientists were very puzzled. They didn't quite know what to do with this species. For the baccalaureate, you need to know these differences because you can have questions about these two types of characteristics. Be aware. Be aware of what, you may ask? Well, be aware that what we've just talked about were pieces of knowledge and theories that date back to the 19th century. And you know that science changes, evolves with new arguments and new theories appear. So I want you to read carefully the following. The S7 4P biology syllabus mentions the reptile group. However, today, talking about reptiles does not make much sense, and we're going to explain why. Well, with this phylogenetic tree, or cladogram, we can explain why using the word reptile is not adequate anymore. When you speak of a group within a phylogenetic tree, you consider the common ancestor and all of the descendants. The problem is with reptiles corresponds to these groups of species here. But the problem, if you want to link back to the last common ancestor, well, birds wouldn't be part of that group. To consider a group, you need to, I'm going to change color. In this case, you would need to consider the common ancestor, which is in C here, and all the descendants. This would be what we call a monophyletic group. So one common ancestor and all the descendants. So reptiles would be considered a paraphyletic group. So in today's knowledge, you can't really say that it's one group because you're excluding birds from the common ancestor. I have a question for you. Do dinosaurs still exist? You probably think that this is a weird question because you're probably thinking that you learned when you were in primary that dinosaurs have disappeared, and you might have in mind this kind of image with this theory that a meteorite was the cause of the extinction of dinosaurs. Well, you're partially right. Indeed, dinosaurs, most of them disappeared 60 million years ago. 60 million years ago during the Cretaceous Paleogene crisis. To be precise, it was the impact of a meteorite and lava from huge volcanoes which created gases, etc. So it's a little bit more complex, but indeed that's what caused the extinction of most of the dinosaurs. However, you might be surprised to hear this, but there are still living dinosaurs today. And you're probably thinking, why? Well, again, we're going to explain this thanks to a phylogenetic tree. Now then, when you speak of a group in phylogenetics, you need to consider, as we said earlier, the common ancestor and all of the descendants. The thing is, if you speak of dinosaurs, so Dinosauria, the common ancestor would be here, and that means that all these species would be the descendants of this common ancestor. This means that Birds, phylogenetically speaking, they are dinosaurs. They are cousins of Archeopteryx and other dinosaurs that you may recognize. So, in today's knowledge in biology, we can say that birds are remaining dinosaurs. So you can tell that to your friends and family that there are still dinosaurs, and well, birds are the last group of species of this big group of the dinosaur family. For the baccalaureate, what you really need to focus on is the name and be able to recognize Archeopteryx, and also you must be able to state a few of the characteristics that we talked about. So what you have here, the characteristics of a reptile, of a bird, and those which are common to reptiles and birds. I'll let you look at the answers which are in your booklet, just for you to know that the few things I wanted you to be aware of, they're not strictly part of your syllabus, but I think it's important as your biology knowledge to know a little bit more about how Archaeopteryx, birds and dinosaurs are considered today. But for the baccalaureate, you can focus on this back exercise and that will give you more or less what you need to know. To finish this video, I found a little song about Archaeopteryx. I'll let you listen to it. Hope you enjoy it. That's all for today. Goodbye.
Archeopteryx, a bird-like flying dinosaur. Archeopteryx, with a mouthful of teeth. Archeopteryx, a long bony tail and then 2 feathered wings and 3 claws on each. Archeopteryx, from the Jurassic period. Archeopteryx, been found fossilized.